I hope they aren't over here, but still. Okay, it starts. Okay, last night we made a very good observation, a breakthrough in our theory. We found out a new field called the badmintonic field. We got properties of this field. We have found out the mass of the particles in the field when they don't exist elsewhere. We have found its Compton length, its de Broglie wavelength, and their energy particles. Yeah, I know the theorist.
That should be clear whether you are a theorist or an experimentalist, because that was the confusion.
I'm a president.
We don't do anything, just come to president.
No, I have a vision. Okay, yeah. All attributes to Siddharth Khare, Atul Abhale, Sanjiv, Siddul, and the two Gayatris, Urankar. It's a joint MSc collaboration. It's like a second project.
We have extended it to the first year also.
We are another of the particles. Okay. We have observed the mass to be 60 kgs. And we use lambda h by b, the body statement, and I won't calculate its long, so it's too small. The weight is the orders of 10 raised to minus 44, so this is not significant. What is significant is we get omega from it, okay? And the significance is of the badmintonic field. This is a badmintonic field. Here is a barrier for the neck. Okay, and here is another barrier. And the particles were observed to go harmonic oscillator, show the properties of the This is a crude approximation. And as you all know that energy is half h cross omega. We know lambda, we know omega, from which the energy of the ground state.
That's what I'm saying. You are assuming that it's in the ground state.
Yeah,
the ground state in the excited state.
It can be in the excited state. The whole issue of the ground state energy level is in the order of something like so many joules. So they are highly excited particles. For the ground state. So in the excited state, you should stay away from it. Like I told last time, the basic field that still remains is the Gaussian field. The badmintonic field may be just a part of it, a special case. That is something different. So we have studied, especially Atul Abhale and Siddharth have found out the properties, the character of the Gaussian potential. And suppose it is very fascinating to see. It follows the same potential. This is like the hydrogen molecule. It follows the same potential. Here is a distance r, okay, and here is a potential. Here is a repulsive potential. Here is the attractive potential. We should understand there are two forces that act over here. There are two particles, first of all. One is either Nakatons or Nakaton over here.
Vijay, you have last minute.
Come on, it's interesting. Right? The whole point is the attractive force is all given by the Nakatons. And the repulsive field is all given by the Gonons. So, at an equilibrium distance, they come and over here. If the Nakaton behaves too excited and tries to come here, there is a huge repulsion. In fact, I'm so sorry, this is a data.
That's what I was going to ask. Like, two particles are, Gaussian is a field. There are two particles.
And the field is quantized, right?
Potential is between which two particles? So this is the potential experienced by one of the particles.
The whole thing is very fuzzy. There is a Gaussian field, but we do not know if the Gaussian particle exists. It's like a duality. Sometimes it is so particle nature. Yeah.
But you should specify that. I specified that the questions are coming up right in between. It's fine.
No, it's not fine. I lose my time.
Whatever. Anyway, you're done with the final.
No, I lost my time by questions.
Yes.
You wasted my time there also. Okay. So the whole point is, okay, where was that? Yeah, this is for the cartons. But for Nakatons it is even worse. Equilibrium distance is bad. Very huge. I think it is all got to do with the excited energy level. The Nakatons are very excited particles and Nakatons are not that excited. So, I think that's it. So these are the findings. Okay, yeah, they have formed the form of the same thing, the same form. Minus 1 by r square is the potential. And yeah, I think those are the findings. So any questions?
Any more questions? Only one question will be taken. Anyone?
Last time you said that there doesn't exist anything like mass, and now you are saying that there exists mass.
This is the whole concept.
Yeah.
The whole problem.
Isn't it contradictory?
No.
It is not contrary.
Yeah. Yes.
See, that is because badmintonic field, how do I say? See, badmintonic field, okay. You take the badmintonic field in which the mass exists. But the whole point is Gaussian field is the base field. It is the original field. So what happens is, we have in our observation here, we see that there is a Gaussian placed here and there is a Gaussian placed here, because of which the particle oscillates. The particle oscillates because when the particle gets too close, right, you see this characteristic. It comes the equilibrium distance is small. So there is repulsion because of which the particle again comes. So this is effect of many Gaussians. And here the badmintonic field is getting 3-dimensional. Right.
My question is mass.
Mass?
Yeah.
So that is the whole issue. When many Gaussian fields exist, how does mass exist? The effect of mass comes from the interaction of many fields. In a single field it doesn't exist. So if the answer is not yet found, how the mass comes from the interaction of fields.
Then how did you calculate mass?
Approximately, we have
particle
calculated.
Okay.
And you know the field.
So we know strength
The
of it.
acceleration, you know the mass.
It was done.
And even the distance is not clear. That r is not clear. With what?
Pankaj, we have your time.
One.
Vijay, ask, are the galvanic field uniform enough, or it occurs in some specific galvanic fields?
See, the strength of the Gaussian field, like I told last time, depends on the ultra model law. Depending upon the model, the field is strong or weak.
Gayatri, symbol.
Vijay, we will start with the second round. Otherwise, we will go all Gayatri, please.
Vijay.
I request.
One.
Please, it's done. Subhash is a request. You can start with the second. Four words, yeah.
Ban, Vodafone, vendor and value. Can I use value less? A vendor was traveling in a van selling a valueless Vodafone phone and nobody got the Vodafone because it's a useless phone. You're supposed to be 5 minutes.
So you have time.
And imagine a vendor traveling in a van, okay, selling out Vodafone SIM cards, who would buy? Seriously, who would buy? Anybody? We can't give
You can.
Okay, thank you. People are long waiting for a theory.
It's not my theory, but most of the credit goes to the people sitting there.